Welcome, this is 810. This is on how to use quadratic functions in real life and what the different terms mean in the quadratic function. First off, the f of t we know is the dependent variable because how it depends on the t. Typically in life, especially when they represent the quadratic with the t, it's indicating time, usually seconds. And the ft, especially if they're showing the path of like something falling or shooting into the air, the ft is the height in that moment of time. So it's dependent upon how many seconds that it's been in the air as to what height it is. Now, if we put a 0 in here for ft and we make it equal to 0, then we're asking at what time was the height 0, which would be when it lands. If we do the 0 in the t, which means that we're plugging 0 in for the t, that would end up being this HO value, which is your initial height, the height in the very beginning. So for this little guy here, I drew two different scenarios. One, a kid down on the ground, he throws a ball in the air from a 3-foot height. That's what height his arm is from the ground when he throws it. And this guy, he throws his thing in the air off of a 48-foot cliff, or I should say the 48 feet goes up to his hand actually. So he has 48-foot height. So if we were to show those in two different equations, we would show this guy, f of t, or we'll call it g of t, just to give it a different name, separate it from the initial one that I showed you. We always have the negative 16, because that is our gravitational force. Now when you get in my Algebra 2 classes, we have some fun. We go to the moon, we go to Mars, and we change that gravitational force. Okay? Now, the vt, that's your initial velocity. They always have to give that to you. For this guy, it's 32, so it would be plus 32 times the t, plus the initial height of 48 feet. So that's how you would write the equation for this situation. For the other situation, let's call it, it doesn't matter, mt. Now, typically the reason that we make it ft is usually not just function, but oftentimes we think of the feet. But it's important that you distinguish that you're talking about a different equation. So this one matches to this one matches to this scenario. That's why we always change that front letter. Okay, so we have a negative 16 for the gravitational force times the t squared, plus 64 feet per second, so it's 64t, plus 3. And that's how we would write the initial quadratic formula in order to solve for that scenario. Now, I went ahead and I took these and I set them to find what x or t would be. Should have a t there. What t would be when the ball lands on the ground. In other words, I set them equal to 0 and I started factoring. This one was real easy. I divide everything by negative 16 to get it out of there. You always want to get rid of that negative when you're factoring. And then I did the x gain, because what I had left was t squared minus 2t minus 3. So I knew that negative 3 and a positive 1 would work as my middle terms. Because there's a 1 right here in front of this, I could go straight to my answer and put the positive 1 and negative 3 in there. The negative 16 doesn't have a variable, so we don't worry about it being a 0. We set each of these to 0, zero product property, and we solve it, and we get t as negative 1 and t as 3. So in other words, in order for that height of this guy's object to be 0, it would need to be in that 0 clear down here. It would either take 3 seconds or negative 1 seconds. Hopefully you're saying there can't be a negative time. You're correct. That negative 1 is if we came back here theoretically behind the y-axis. We don't even look in that quadrant. because we can't have a negative time. So it's 3 seconds is our solution. Okay, what would the maximum height be? Well, the maximum height would be right here at the vertex. Okay, so if we wanted to know the maximum height, we'd need to find the vertex. This is now in intercept form. You know how to find the vertex, find the halfway point between them, plug that in, and then you'll be able to find your vertex. Okay, that'll find your, I shouldn't say your vertex, it'll find your A of S. Be looking at this, you find the halfway point, that'll give you your axis of symmetry, and then once you have that value, that'll tell you how many seconds it is to get to the height. The A of S will tell you the seconds, because it's an X value or a T value, so it tells you the seconds to get to the maximum height. And once you plug it in there, the Y part of the vertex is going to be that maximum height, because your Y is in feet. Okay? What does f of 0 mean in the context of the problem? I already explained that. Back up the film and you'll see what I said when you plug 0 in. Is the domain restricted? Absolutely. The domain, remember, is our left-right. And so right here when the ball first gets thrown, that's at 0 seconds, and it only goes from 0 to 3 seconds because that ball does not continue to travel through the earth. So domain restrictions would be t is less than or equal to 3, greater than or equal to 0. Okay, over to our other equation. This little guy that's down here on the ground that can throw twice as fast. When I looked at factoring it down, it wouldn't factor. So instead I went with the quadratic formula. Go back to some of the former lessons if you've forgotten what it is, but I wrote it here for you. I plugged in the values, and I ended up with the discriminant being, this is still over negative 32 by the way, the discriminant ended up equaling 4,288, which came out to 32 radical 67. So I could cancel the 32s, and I had a radical 67. So this is an approximate. It's not an exact answer, but radical 67 is very close to radical 64. Radical 64 is 8, so I rounded it to 8. Negative 64 over negative 32 is equal to 2. So I said 2 plus or minus 8 will give us an approximate of the seconds. So it's a negative 6 or a positive 10 seconds. Okay? So the negative, of course, comes from back this way. The positive goes that way. And I would say that he was actually throwing right at the edge of the cliff if you're looking at your XY axis. Otherwise, it wouldn't make sense to have him moved over. Okay, I just couldn't draw him that way. So, same thing on him. If you find your axis of symmetry, which now that you know that it's negative 6 and 10, you can do the same thing as you did here to find your axis of symmetry. Even though this one's just theoretical, find the halfway point. That'll tell you when it's at the maximum height. And then plug in that A of S, which is your seconds to the maximum height, and you'll be able to get your feet for how high up the ball was. F of O, what does it mean? I already told you on that first board. Go back on the film if you didn't catch it. And that is the end of this lesson. We'll see you in class.